The first thing we need to do is write a correct balanced equation. We have zinc, Zn, plus hydrochloric acid. All acids begin with an H. Since it has hydro, it's off the periodic table, so it's Cl1. So this is going to be HCl. We have an element and we have a compound, and so this is single replacement, and so we need to look up zinc, metal, and hydrogen, which is the ion here. Since the metal is higher than the ion, this reaction will occur. So zinc will replace hydrogen, so this is going to be cationic because a metal is replacing a metal, and hydrogen in the front behaves like a metal. So zinc's new partner is going to be chlorine. Charge of zinc is 2, chlorine is 1. Crisscross, so ZnCl2. What's left over is hydrogen, which is a diatomic. So in order to balance it, I just put a 2 in front of HCl. So we need to calculate the moles of HCl to react with 8.25 moles of zinc. So I'm going to start with what's given, 8.25 moles of zinc. Diagonal units have to be the same. So this has to be moles of zinc. We could go to moles of HCl because this is mole ratio. Mole ratio is when we can change elements in compound. So we look at our balanced equation. The number in front of zinc is 1 right here. The number in front of HCl is 2 right here. So 8.25 times 2 divided by 1 gives you 16.5 exactly. So now I need to do sig figs. My diagonal units cancel out. This is what I'm looking for. Conversion factor doesn't count. There's 3. So I have 3 in my answer. So this is moles of HCl. In the next problem, we are finding the mass of zinc chloride when we have grams of zinc. So we're going to start with what's given, which is 0.238 grams of zinc. Diagonal units have to be the same, so grams of zinc, grams of zinc. This is molar mass. That tells you 1 mole of zinc off the periodic table is 65.39 grams of zinc. If I stop here, I'm going to be at the moles of zinc, and we don't want that. We want the mass of zinc chloride. So diagonal units, moles of zinc, moles of zinc. I could go to moles of zinc chloride because this is mole ratio. The number in front of zinc chloride is 1 in the balance equation. The number in front of zinc is also 1. So it's a 1-to-1 ratio. I need to continue on because if I stop here, I'm at moles and I want mass. So moles of zinc chloride, moles of zinc chloride. There is 1 mole. And so I need to do the molar mass of zinc. There is 1 zinc, which is 65.39. Chlorine, there's 2 of them, which is 35.45. And if you add up all of this, you should get 136.29 grams per mole. So that tells you 1 mole of zinc chloride is 136.29 grams of zinc chloride. So now I multiply everything because my diagonal units cancel out, and this is the unit I want, grams. So 0.238 times 1 times 1 times 136.29 divided by 65.39 times 1 times 1. This will give you 0.49605. So now I need to do sig figs. Conversion factor doesn't count. Conversion factor doesn't count. Conversion factor doesn't count. There's 3. So 1, 2, 3. I look 1 to right, so it stays 0.496 grams of zinc chloride. Pause the video and solve these on your own, then check your answer. The equation is the same as above. So I'm just going to rewrite the equation down here. So in this problem, we want the volume of hydrogen is that STP when we start with 25 grams of HCl. So we're going to start with what's given. Diagonal units have to be the same. Grams of HCl, grams of HCl. We know this is molar mass, so this is 1 mole of HCl has to equal to its mass off the periodic table. There's 1 hydrogen, which is 1.01 gram. There is 1 chlorine, which is 35.45 grams. So if I add all of this up, it's 36.46 grams of HCl. So I have 36.46 grams. The grams cancel out. If I stop here, I'm at moles of HCl, and we want the volume, so I need to continue on. Moles of HCl, and we are going to hydrogen gas. So we could go to moles of H2 because mole ratio lets you convert from one element to a different element or compound. So the number in front of H2 is 1. The number in front of HCl is 2, so I put a 2. My diagonal units cancel out. I'm at moles, and I do not want moles. I want volume, which is liters. So I need to go one more step. Moles of H2, 1 is equal to 24.4 liters of H2. 25 times 1 times 1 times 22.4 divided by 36.46 times 2 times 1. You get 7.6796. Now I need to do sig figs, conversion factor. There's 3. There's a decimal significant digit in front, that's 0 significant. So 1, 2, 3, I look 1 to the right, the 7 becomes 8 liters of H2. Calculate the moles of hydrogen gas when we have 99.3 grams of zinc chloride. And again, we are going to start with what's given, 99.3 grams of zinc chloride. Diagonals have to be the same, grams of zinc chloride, grams of zinc chloride. This is equal to 1 mole of zinc chloride because this is molar mass. We know that the mass of zinc chloride is 136.29 because we added this up earlier above. The grams of zinc chloride cancel out. If I stop here, I'm at moles of zinc chloride, which I don't want to be at. I want hydrogen. So I need to do diagonal units, moles of zinc chloride. This is mole ratio, so I could go to moles of hydrogen. The number in front of hydrogen is 1. The number in front of zinc chloride is 1. Diagonal units cancel out. We are at moles of hydrogen, which is what I'm looking for. So I'm going to multiply 99.3 times 1 times 1 divided by 136.29 times 1, 0.7289. Now I need to go back and do sig figs. Conversion factor doesn't count. There's 3, so my final answer has 3. 1, 2, 3. I look 1 to the right. 0.729 moles of H2. So when we are doing stoichiometry, remember to write a correct balance equation, always. Second, start with what's given. If you get stuck, make sure you write your diagonal units because diagonal units have to cancel out. Always make sure you write your element or compound because that's how you keep track of it. Molar mass, molar volume, Avogadros are always equal to 1 mole. Mole ratio will sometimes be equal to 1, other times it will not be. It is the coefficient of the balance equation. Last, double check that all the units cancel out except for the unit that you are looking for. Do sig figs and use proper units. These problems are a little bit harder because they combine more than one concept. This is page 77 in your work packet, number 8. So here we have 0.255 gram sample of an unknown compound that contains carbon, hydrogen, and oxygen that undergoes a complete combustion to produce CO2 and H2O. So we know the general formula for a combustion reaction is we have C which is an X because we don't know the subscript, H, Y because we don't know the subscript, O, Z because we don't know the subscript. This is going to react with O2 because it's a combustion reaction, and it's always going to produce H2O and CO2 because it goes to completion. So we are looking for the empirical formula. We know that we have 0.3664 grams of CO2 and we have 0.1500 grams of water. By looking at this equation, we know that all the carbon that is in CO2 was provided by the hydrocarbon because that's the only location we find carbon in the reactant side. Same thing for hydrogen. All the hydrogen in water was provided by the hydrogen in the hydrocarbon. So since we are solving for empirical formula, we need to find the number of moles of hydrogen and the number of moles of carbon. So we're going to start with 0.366 moles of CO2. Diagonals need to cancel out. Grams of CO2, grams of CO2. We're going to go to moles of CO2. We know this is molar mass, and we find the mass of CO2 off the periodic table. We add 1 carbon and 2 oxygen to get approximately 44.01. If I stop here, we have moles of CO2. Since we are solving for empirical formula, we want the element. The element here is carbon. So diagonals, moles of CO2, moles of CO2. Since this is moles to mole, which is mole ratio, we could go from moles of CO2 to carbon. The only time we could change elements and compounds to different elements and compounds is mole ratio. So if I look at CO2, for 1 molecule of CO2, I have 1 carbon and 2 oxygen. Since moles measures any amount, if I have 1 mole of CO2, I have 1 mole of carbon and 2 moles of oxygen. So the moles cancel out of CO2 and we are left with moles of carbon. And this is where we want to stop, because when we do calculate empirical formula, we always have to convert to moles of the element. Usually, when we solve for empirical formula, we stop here at moles because in order to solve for empirical formula, we have to convert everything to moles first. However, in this situation, we have carbon, hydrogen, and oxygen. Since we don't know the amount of oxygen, we have to convert the moles of carbon into grams of carbon because the sample weighs 0.255 grams. That is the mass of the carbon element, the mass of the hydrogen element, and the mass of the oxygen element. So if we know the mass of the carbon and the hydrogen, we could calculate the mass of the oxygen. So we need to go one more time. So moles of carbon, we could go to mass. This is molar mass. So all the units should cancel out, and when you multiply the top and multiply the bottom and divide the two, you should get 0.1000 grams of carbon. We're going to repeat the procedure for hydrogen. So we're going to start with 0.1500 grams of water. Diagonal units, grams of water, 1 mole of water. We know this is molar mass. We find the mass off the periodic table. We add 2 hydrogens and 1 oxygen to get 18.02 grams. The grams cancel out. Moles of water. If I have 1 molecule of water, there are 2 hydrogens and 1 oxygen. So if I have 1 mole of water, I have 2 moles of hydrogen and 1 mole of oxygen. Since we are looking for hydrogen, This is going to be 2 moles of hydrogen. We are going to grams, so moles of hydrogen, molar mass again. 1 mole is equal to its mass of the periodic table, grams of hydrogen. So again, multiply all the top, multiply all the bottom, and divide, so this becomes 0.01678 grams of hydrogen. The original sample contains carbon, hydrogen, and oxygen, and it weighs 0.255 grams. Mass of the oxygen in the unknown substance is going to equal to the total mass minus the mass of carbon minus the mass of hydrogen. Total mass is 0.255 grams minus mass of carbon, which is 0.1000 grams, minus the mass of hydrogen, which is 0.01678 grams of hydrogen. This should equal approximately 0.1332 grams of oxygen. So the reason we can't use stoichiometry to find the oxygen in the CHNO using water and carbon dioxide is because some of the oxygen is provided from the O2. And we don't want to include the O2 because we know that that is not part of the unknown compound. So now that we have the mass of each of the elements, we could solve for the empirical formula. So empirical formula, we're going to convert our percent to mass, but it's already in mass in grams. So now we go from mass to moles. We're going to start with 0.1000 grams of carbon, 12.01, 1 mole of carbon. Hydrogen is going to be 0.01678 grams of hydrogen. This is 1.01 grams of hydrogen to 1 mole of hydrogen. And then for oxygen, it's going to be 0.1332 grams of oxygen. The diagonals, remember, always have to cancel out. This is 16 grams of oxygen to 1 mole of oxygen. So for carbon, you get 0.00833 moles of carbon. For hydrogen, you get 0.0167 moles of hydrogen. And for oxygen, you get 0.00823 moles of oxygen. So now we divide by small. So the smallest number here is the oxygen. So this is going to be 0.00823 divided by 0.00823. This is 1 exactly. So we're going to divide the top by 0.00823. In the hydrogen, we're going to do the same thing. 0.0167 divided by the smallest point, 0.00823. So for the carbon, we get 1.01. For the hydrogen, we get 2.03. So these are all roundable, so we don't need to multiply till whole. So the carbon, there is 1. For the hydrogen, there is 2. For the oxygen, there is 1. So my empirical formula is C1H2O1. Pause the video, solve this problem on your own, and then check your answer. 0.487 grams of quinine is combusted to found and produce 1.321 grams of CO2, 0.325 grams of H2O, and 0.0421 grams of nitrogen. They want you to find the empirical and molecular formula. Remember, empirical formula we must always be in elemental form. So that means that we have to make CO2 into carbon, we need to make water into hydrogen, and nitrogen is given as is. Since this is combusted, there is also oxygen present. So we're going to start with 1.321 grams of CO2 and find the element carbon. So grams of CO2, which is 44.01 grams to 1 mole of CO2. This is molar mass. Moles of CO2, 2 moles of carbon. Remember, we can only change elements and compounds when we go through mole ratio. So the units have to be moles over moles. So for 1 molecule of CO2, there is 1 carbon and 2 oxygen. Since moles measure any quantity, 1 mole of CO2 will have 1 mole of carbon and 2 moles of oxygen. The moles cancel out. Here, we do not want to stop at moles. We want to go to grams because we need to find the amount of oxygen present in quinine. And since the sample mass is given in grams, we have to convert it into grams. So we go one more time, moles C to moles C. This is going to be molar mass, 12.01 grams of C. So 1.32 times 1 times 1 times 12.01 divided by 44.01 times 1 times 1 gives you 0.3606 grams of carbon. We're going to do the same thing for water to find hydrogen. So we're going to start with 0.325 grams of water. Diagonal units have to be the same. So grams of water. This is 18.02 off the periodic table. It's equal to 1 mole of H2O. Grams cancel out. Moles of H2O. So for 1 molecule of H2O, there are 2 hydrogens and 1 oxygen. So 1 mole of H2O has 2 moles of hydrogen. The moles cancel out. Moles of hydrogen. 1 mole is equal to 1.01 grams of hydrogen. So we multiply out the numerator, we multiply out the denominator, and divide. It's 0.03640 grams of hydrogen. Nitrogen, we have to calculate. The nitrogen we also have to calculate because nitrogen by itself is a diatomic. So we have 0.0421 grams of nitrogen. There's 28.02 grams of nitrogen to 1 mole of nitrogen. Moles of nitrogen. In diatomic form of nitrogen, there are 2 moles of nitrogen. Continue on, moles of nitrogen. 1 mole is 14.01 grams of nitrogen. So multiply out the numerator, multiply out the denominator, and divide the 2, and this will equal 0.0421 grams of nitrogen. So to find the mass of oxygen, we're going to take the total mass given minus the mass of carbon minus the mass of hydrogen minus the mass of nitrogen. So this is equal to 0.487 grams minus 0.3606 grams minus 0.03640 grams of hydrogen minus 0.0421 grams of nitrogen. So it becomes 0.0479 grams of oxygen. Now that we have all the masses of the unknown, we can now start our empirical formula. First step is percent to mass, but since it's already in grams, we could go from grams to moles using molar mass. So we're going to start with 0.3606 grams of carbon. Diagonal grams carbon, grams carbon. Remember, empirical formula is always one element. There is no diatomics. Moles carbon. For our hydrogen, it's going to be 0.03640 grams of hydrogen. Diagonals, grams hydrogen, 1.01 to 1 mole of hydrogen. For nitrogen is 0.0421 grams of nitrogen. 14.01 grams of nitrogen, 1 mole of nitrogen. Last one is 0.0479 grams of oxygen, 16.00 grams oxygen to 1 mole of oxygen. So if we multiply all these out, for carbon you get 0.0300 moles of carbon. For hydrogen we get 0.036114 moles of hydrogen. For nitrogen, we get 0.0030 moles of nitrogen. And for oxygen, we get 0.002994 moles of oxygen. Next thing, we're going to divide by small. The smallest number is oxygen. So carbon, 0.00300 divided by 0.002994. It's going to equal 10.00. For hydrogen, it's going to be 0.036114 divided by 0.002994. This is going to equal to 12.038. For nitrogen is 0.0030 divided by 0.002994, which is equal to approximately 1.00. And then the last one is divided by itself, so it's going to be exactly 1. So the last line multiplied to a whole we don't have to do because all these numbers could be rounded to the next number. So for carbon we have 10. For hydrogen we have 12. For nitrogen we have 1. And for oxygen we have 1. So our empirical formula is C10H12NO. We need to look for the molecular formula. So the molecular formula, remember, is molecular formula mass over empirical formula mass. The molecular formula mass was given as 324 grams per mole. So we need to find the empirical formula mass. So that's going to be 10 times 12.01 carbon, grams of carbon, plus 12 times 1.01 grams of hydrogen, plus 1 nitrogen, which is 14.01 grams, plus 16 grams for 1 oxygen. This will equal to 162.1 grams per mole. So now I put the molar mass of empirical formula below it. I divide this, I get around 1.998, which is approximately 2. If you divide the molecular mass by empirical formula and you are not close to a whole number, you did your calculations wrong. So that means my molecular formula is going to be twice as big. So my molecular formula is going to be C20H24N2O2. On this one, we are calculating the molar mass of a metal that forms an oxide having the empirical formula of M2O3. It contains 68.0% of metal of mass. Identify the metal. So we know the total percentage of the metal plus the oxygen has to equal to 100. So 100% is equal to the percent of the metal plus the percent of the oxygen. Since we know that the metal is 68.04%, we can find the percent of the oxygen by rearranging. Percent of the oxygen equals 31.96%. So we could find the mass of oxygen in this compound because we know the percent of oxygen is equal to the mass of oxygen divided by the total mass. So percent of oxygen times 100. So percent of oxygen is 31.96%. The mass, there are 3 oxygen, so it's going to be 3 times 16.00 grams divided by the total mass times 100. So we're going to rearrange this to find the total mass. I need to multiply by total mass on each side. So if I multiply by total mass, this cancels out, this cancels out. And since we're doing math, we need to do the same thing. So we have total mass on that side. Since we want to isolate total mass, we need to divide both sides by 31.96% divided by 31.96%. So if you clean this up a little, the total mass is going to equal to 3 times 16 times 100 divided by 31.96%. If you do the math correctly, you should get approximately 150.2 grams as your total mass. Since this is my total mass and I know my mass of the oxygen, we could find the mass of the unknown metal. So we're going to rewrite this as total mass of compound is going to equal to the mass of oxygen plus the mass of the unknown metal. So this is going to be 150.2 grams. Mass of the oxygen is 3 times 16.00 grams plus mass of the metal. So mass of the metal is equal to, so the mass of the metal is going to be 102.2 grams. But if I look at my formula, the formula was given as M2O3. There are 3 oxygens and 2 unknown metals. So what I need to do is I need to divide this 102 total mass divided by 2 to get 51.1 grams of the unknown metal, which is close to vanadium. So a lot of these problems we did today are interrelated. Practice the ones in the book and the packet to get faster and to better apply the concepts.